Okay, so we're going to talk about SQL today, and in particular PostgreSQL. But let's just kind of like talk what this SQL term is. So you'll hear this term SQL. You will hear it called either SQL or SQL. It's the same thing. Just depends on how you want to say it. But what this really is this is structured query language. That's what it stands for. And this is a programming language we use to talk to databases. So what we've been doing so far is we've been using Rails and like Rails models to interact with our database, which is fine. And behind the scenes, the Rails models is going to be using SQL. So I think we all know what a database is, and a database is it's just essentially a way to collect and organize data to easily get retrieved. I think one way I like to think of a database is just a whole bunch of like Excel spreadsheets, with a whole bunch of tables that's storing your data. It's kind of like a high level way to think of it. Now there's a lot of different kind of SQL databases. There's SQLite, MySQL, Postgres, Oracle, Microsoft SQL Server. So all of these support the common SQL like features and language, but they're going to differ a little bit from each other. But I think this is a case where these languages are very much a lot more similar than they are different. It's pretty easy to go back and forth between them. So yeah, for this, we're going to be using PostgreSQL out of these ones. So it just works well with Rails, and it works Rails with the production. So that's why we use PostgreSQL. There's some tools we're going to use today. We're going to use SQL Electron today. That's going to give us a way to like interact with our databases. It's going to give us a user interface to directly do SQL calls. Yeah, and Postgres also plays nice with Rails, and it plays nice with Heroku, which we'll get to maybe next week. And Heroku is a way we're going to like be able to actually push our websites up to production. So how do we interact with our Postgres database? So we're going to use this. Let me just Slack this out. Yeah, I heard Mike ask about PG admin. That's one tool we can use to work with our database, but we're going to use SQL Electron. So let me Slack this out. Oops, Nadia Popovich, okay. I was reading an article about a hockey or some hockey fan that was like banging on the back of a glass because she saw a mole on the coach's or like staff's neck, and it turned out to be cancer. So she's like, hey, you have a bump on your neck, go get it checked. It's kind of funny. Cool. So go ahead, and I actually think I need to download this too. That thing I just threw out in Slack. Which one do we want to download? Is it one? Okay, 1371. So we're going to want to do the 1.37.1 DMG. So go ahead and throw that inside of your applications folder. All right. If you ever get this warning or like it won't open it up, it's giving us this because we didn't download this from the App Store. So Apple's just not letting us open it up this way. So there's another way you can open this up, and that's just to right click on it and click open. And then that gives you this warning box, but which actually gives you an option to open it. So cool. So once you're finally able to open it, here it is. It's just this app called SQL. I can never say this. It's SQL Electrons. Okay, anyway, I'm not even gonna try. There's actually it has a weird name. It's trying to combine SQL and Electron, because there's a web app, or there's a this language. It's not a language, it's a framework called Electron, and this actually allows you to write web applications in React. And this SQL Electron actually is written in React. You can actually go like, when there's a way to like toggle dev tools, you can actually like come in. Now this is not a web application. I downloaded this from a website. I'm running it, from my computer. It's a desktop application, but I can come in here. I mean, not that you need to do this, but I can like toggle my dev tools. I mean, it's like styled with CSS. How do I get there's like, you can see this is like written in JavaScript. Let's try to see if I can find any like React components in here. Oh man, there's a way to find them. Not that like we need to change them or anything. I just kind of wanted to show you like, here's a desktop application that is written in JavaScript. And really it's written in React. Just can't really find any of it. Okay. Maybe it's in the file system. Nope. All right, cool. So we just need to do a couple things to get this set up. And so what I'm going to do is I want to add a server. So let me just make sure that I have the right stuff going on here. 1 second. That is somewhere. All right, let's see if I can do this from memory because I can't find it. All right, so think the name, we can name this anything. So DB. All right, it's not really, or James server. Doesn't really matter. All right, then the database type, I'm going to select PostgreSQL. Okay, cool. That was the thing. Okay, so it automatically did the port. That's cool. The local host is going to be, the server address is going to be local host. So I just gave it a name, selected PostgreSQL, put in localhost here. I can test. So that's connection test, that's successfully connected. So that's good. If that's successfully connected, I can go ahead and click save. And now I can click on this. When we do this, and we'll do this a lot this week, this is a way I can like come click on this and I can see all of my databases. Now, since this is a new computer, I don't have too many databases going on here, but you should be able to see all your Rails projects in here, all of your Rails databases. And this is a way, and we'll show how to do this later, but this is a way, or this is a tool we can then go into your databases and go ahead and write some SQL. I could show this just really quickly. We could come in, create a new Rails project. Give it a Postgres database. API flag. So I have this project I called Testio. It's just a Rails project. You don't have to do this because I'm just going to like delete this in like 10 minutes, but just watch. I have this Testio project. Come here. It's not inside of here. I might have to restart it, but definitely one thing I need to do first is I need to do a Rails create. See if that throw it in here. I'm gonna maybe ask to reload. Let's go ahead and open up SQL Electron again. Cool. See, now I have these new databases, this Testio development database and this Testio test. So all of your databases, you're going to find for each Rails project, you're going to find two databases for each project. You're going to find a development one and a test one. There's actually a third database that you're going to have, which is your production one. And that database is actually going to live on a server somewhere in like the cloud. So for your local machine, you're just going to have these two. So I could come in here, do a Rails model thing as a name. And do a Rails DB migrate. maybe step into my console and do a thing. Opt create, just create one. That didn't create anything. Thing.create. Another one and another one. Cool. So what we have here is using my Rails console, I've migrated my database and I created 3 things. I'm going to see if that actually came up. So if I go look at like my development database, look at my, this actually, if I have to restart this. Where is it? Tables. Might need to quit this because it might not. If you're like changing your database, I think you might have to restart this. I don't think it automatically updates. But what I can do is I can connect to this server we just created. I can go into my development branch, connect to that. Then I can come in here and I can start writing SQL, which we're going to talk about today. So I need to oh, I forgot it from. Did I not migrate my database? Oh, I'm in the wrong database. Duh. Okay, so I clicked on this wrong one. I need to go to the test yo. I need to connect to the right database. And now I can write like a SQL statement, which we'll talk about today. I'm in my test yo.
Try putting things in quotes.
I think you're in your just Postgres.
Oh, I am still in the I'm still in the wrong one. Yeah, I'm like I'm still in this one. So, yay, there we go. Easy select start. So I'm in my yeah, sorry, I was in the wrong database. Now I'm in the right one. So the test development, and I can write some SQL. And notice those are the 3 things I created in my database. And we're going to use this tool a lot. So, because what we're going to do is we're going to write more complicated SQL statements. We're going to try to figure out, and then we're going to throw those into our Rails app. But SQL Electron is a good way to just test out your, it's kind of like a nice little sandbox to get these working. Cool. So if I come here, I should be able to come in and now see here I have this public things. Oh, that is actually just doing it. But I can come and look at this knows this things table has an ID, has a name, and it's telling you the types. So it's a good little, this is a nice little tool to use when you're doing SQL, some more advanced SQL stuff. All right. So we're going to get into this, but before we do, I kind of just nerding out a little and talking a little about data. But first, did anyone have any problems setting this up? You didn't need to set up a Rails project. I mean, just setting up SQL Electron to the point where you have this server running. So you can open up SQL Electron, SQL. I really don't know how to say that. And you connect. That's all you really need to be able to do. All right.
So I think if you want to refresh SQL Electron, you can just click that plug button on the right. Yeah, and that'll just refresh it.
Okay. Reconnect. Yeah. All right. That makes good. Yeah. Close or reconnect. Cool. So let's I'm going to kind of step away from a little from SQL Electron, and I kind of want to talk about data, because we've been using or when we work with like Rails or JavaScript, I've kind of been stressing that it's kind of important to think about what kind of data we're using. And so when we start to work with Postgres and SQL, we're going to see they have their own specific data types. And some of the most common ones that you'll see is things like an integer, a varchar. You can kind of think of this as like a string, or just, kind of text. We have Boolean, that's true or false. We have some dates. We have text. So we have time and timestamp. So these are just kind of some of the basics. But if we're to like look at all the data types, here's kind of all of the data types in Postgres and SQL. So something I would just want to, there's quite a bit. I just kind of want to like pick out, maybe like look at some of the like number types. So we have a big int, which is a signed 8-bit integer. We have something that's called a big serial. That's an auto incrementing 8-byte integer. Where's some more of our number types? We have a double precision. It's also called a float. Double precision floating point number, 8 bytes. We have a integer. That's a signed 4-byte integer. What else do we have? Where's some more numbers? We have a small int and small serial. So the point here I'm trying to make is like, there's like, I don't know, I didn't really count them, but there's maybe like 6 or 7 different ways to represent a number. Does that seem a little weird? Maybe like 3 different ways. There's like a couple different ways to do an integer. There's a big int, there's a integer, and then there's a small int. So there's like 3 different data types to do an integer. Any idea? I think we might have briefly talked about this a little bit, but any idea on like why you would have like all of this variation here? Or why would you have so many different ways to do something, even like an integer? Why do we need 3 different data types for an integer?
Do they let you use different amounts of digits?
Yeah. So that's kind of what it comes down to. So let's just talk briefly about what a bit is and what a byte is. And so when you see like 4 bytes or 2 bytes, 8 bytes, that kind of makes a little more sense what's going on. And it kind of does get to like this combination thing. of like how much data you can represent. So first of all, do you want to learn binary in like a minute? Does anyone know binary? Let's do it. Let's do a brief little like, Fabio, you know it. I feel like it's pretty, this kind of like blew my mind when I learned binary, because can you see my whiteboard? One of the things that like blew my mind when I learned binary is like, I guess I had never really questioned why we count to 10. Like, why do we have 10 numbers? I just never thought of it. Like, for some reason, it just, I just taught as a kid and I never questioned it. But does anyone know why we use 10 numbers? Like, we have 10 numbers, right? We have 0, 1, 2, 3, 4, 5, 6.
Is it 10 fingers?
I mean, no one knows, but that is probably the best guess, is that we have 10 fingers. So for some reason, and it's kind of crazy that like, I don't know if there's different cultures that use a different number system that have more or less than 10 digits, but it seems to be pretty standard, more or less. But yeah, why we chose 10 is no one knows. It's probably because we have 10 fingers.
Sorry, one thing I want to pick up on that is because when I used to spend a lot of time in South Africa, and tribally out there, they think in log terms. So they count logarithmically. So if you were counting half of 10, it would be, or half of 9, it would be 3, because 3 log would be 9. So there are definitely like less Western cultures that think logly instead of like add 1, if that makes sense. So 10 would be half of 100. 100 would be half of 10,000.
Okay. I see. That's yeah.
Well, it works that way because if you were thinking in terms of like, for instance, like listening in decibels, if you want to listen to something and you want it to be 10 times louder, you don't just add 2 stereos. You need 10 times the stereos for it to be twice as loud.
Yeah.
So yes, I think that's how that kind of developed.
Okay. Yeah, it's interesting. Like, because yeah, this is. I mean, the number system's a pretty good system. If you think like, what is it, Roman numerals? Like, that's a pretty bad system. Because if you try to do math on Roman numerals, it's very hard. There was actually 0 was kind of like the concept of 0, I think kind of took a while for people to adapt it. So 0 is like a nifty idea. But anyway, oh, is it not sharing my screen? Or can you see my whiteboard?
We can see your whiteboard, but there's nothing on it.
It's saying it's paused for some reason. Let me reshare it. Okay, yeah. So there we go. Here's our number system, 10 numbers. But yeah, there's really, I think the special thing is like you have a 0, because the magic of like this number system is once we get up to, we start counting 0, 1, 2, and counting starts at 0 technically. Maybe this is why like they do this with arrays, because technically if you want to count all the digits out, you start at 0 and you go up to 9. But then what happens when you get to, you have only these 10 numbers and you want to write the number 10, well, then you start just using the combinations of these numbers. So then you have like a tens place. And so you say, I have 1 10. This is something like you kind of learned in like elementary school. Like this is your tens place, you have 1 of them. And now this is your ones place and you have 0 ones. So this is 10. And like then we have like a hundreds place. And then like if I put a 3 here, I'm saying, hey, I have 3 100s, 110 and 0 1. So this is 310. So that's you know, the 10-digit system. But if we go to a system like binary, it's kind of the same idea, but now we only have 2 numbers. We have 0 and 1. So if I'm counting to like 10, let's say 0, 1, but now I'm out of numbers. So I kind of do what I do with, you know, the 10-digit system. I say, I just reuse the numbers. So this is my 1 spot, but now this is, instead of being my 10 spot, it's just a 2 spot. So I have 1, 2, and 0 1s. So this is 2. And I can just keep going. So if I have 1, 1, if I have this number, that's 1, 2, and 1, 1. So that's just 3. And then I can just keep counting. And this next spot becomes my 4 spot. So this is 4. Because I have 1, 4, 0 2s, and 0 1s. And then this just becomes our little, you know, n squared. And so forth. So here's how you count in binary. It's the same way you would do it with how we do it. It's just we only have, in binaries, we only have 10 numbers. Does that make sense? And then your place, you know, in what is it called? The digit system? Is the digit system actually the one that has 10? I think it is. Like this goes from 1, 10, 100, 1,000. We just add a 0. But in binary, it's just like you're squaring 2. So it's 1, 2, 4, 8, 16, 32, 64. So that's your place, like the count. So let me just clear this. So if I gave you like this number in binary, what number is this? If you're like, and you can always just write, you know, if you're in your head, or do this to get how many, like the value of each digit. So I have 1, 8, 1, 2. That is 10. Cool. Does that make sense? Y'all know binary now. Another, just kind of as while we're on here, so that's binary. Whenever you do CSS and you know you like are writing CSS and you like are giving it a color where you give it like the pound, and then I don't know, it's like F1, 2, 3D or whatever. Do you actually know what you're writing here? Do you know what that is?
It's hex code.
This is this is actually a number that's using a different system. This is hexadecimal. Oh, you said hex code, right? I thought you said text code. Yeah, this is hexadecimal. So hexadecimal is a number system that has 16 numbers. So it has 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. It has 16 numbers. We don't have 16 numbers, right, in our number system. So what they decided to do is just make up some numbers. A is now 10. B is 11. C is 12, D is 13, E is 14, and F is 15. So if I were to ask like, hey, what number is, let's just do something a little simpler, like 1D. What number is that? Well, with hexadecimal, this becomes your 1 spot. Just that's always going to be the 1 spot. And this becomes your 16 spot. So I have 116 and I have 10, 11, 12, 13. I have 13 ones. So this is 16 plus 13. So this is 29, I believe, if I got that right. Another one you might see is the octal system. I think this one's a little less common. Hexadecimal is pretty common, but sometimes you'll see an octal, which is just the number system going from us not to 8. It's 0 through 7. It has 8 numbers. So there's a little bit of yeah, binary and hexadecimal. So now at least when you know, you do like when you're writing CSS and it's like FF, it's really just a number that you could convert to a number you could understand. Cool. Questions on that? This is like high level stuff. You don't really need to, I think it's good just to kind of have like just a rough idea on this. Don't have to be, I mean, I took like a computer architecture class where they just drilled you with this kind of stuff. I feel it's like really interesting, but it is a little nice to know just kind of how this stuff is being stored, but you don't need to spend months on it. But if you find it interesting, I'd look into it. I think it's pretty cool. So let's just look a little bit, a little more into this. Okay, so let's say, we want to store a number in our computer. Now, what we essentially do is, or what people have done in the past is they just kind of come up with methods and like kind of conventions to store numbers. One of the ways they've done, or a pretty popular one, is something that's called a float. Has anyone heard that term, float? I think we've seen that in Ruby, right? There's an integer or a float type. There's actually single point precision and double point precision. So let's kind of look at the difference. So a float is really just a way to, and a single point float in particular is a specific way of how to store a decimal number in a computer. So a single point floating precision is going to use 4 bytes. And a byte is 8 bits. So remember, a bit is the smallest unit, and that can be a 0 or a 1. When we say the word bit, that's all it is. And a byte is 8 bits. I'd like to look this up. I think it's just kind of randomly, they chose 8. I'm not quite sure why 1 byte is 8 bits, but that's just what it is. So when we have a single point when we have something that's 4 bytes, like a single point floating precision, that means we have 32 bits. So I could count these out and there'd be 32. So what this means is with 32 bits or 4 bytes, we have 2 to the 32 combinations that we can create. If you were to go through and like, if I were to have these, so the one way to think about this as a combination, I could have these all be 0 and that would be the value 0. If I had these all filled out to 1, meaning that's the highest number I could count to, and I kind of converted 32 ones from binary to decimal, it would be the number 4.3 billion. So what 4 bytes gives us, it gives us this data structure that gives us 4.3 billion values we could use. So, and if I had a 4-bit integer, and let's ignore this signed. So here's kind of the point. Let's say I have a 4-bit data structure. How high could I count up to? I could go from 0 to 4.3 billion. So if I was doing like a checking account system, maybe and I was trying to like do people's balances, a 4-bit system would probably work for, the majority of people, unless you were like Jeff Bezos. Then all of a sudden in a 4-bit integer, I couldn't store, Jeff Bezos value inside of here. Or does that make sense? I can only, with using 4 bits, I can only count up to 4.3 billion. But that's an integer. So with a float, now there's an issue of how do you represent like decimals. So what they've done, this is just kind of how they designed it, is they just use the first 23 bits to represent the fraction. And then the exponent, they're using these next 8 bits. And then for this 31 bit, this is what's called the sign. And this is like, is this positive or negative? So if the sign is 1, that means it's a negative number. If it's 0, it's positive. So another thing to keep note of when we're talking about like this data, especially with something like numbers, so I'm using 4 bits, so there's 4.3 billion values that I can store with this 4 bits. But with something like a single precision float, we can have values from 1.175 times 10 to the negative 38, all the way up to 1.701 times 10 to the 38. That's an insane range, right? Because these are very big numbers. But what happens is we're skipping a lot of values. How come I can't think of the word? I'm having a brain fart here. Analog. So if you think of something that's analog, like every value, and it's like a clock. When you have like an analog clock, like it's going to show every single value. Like there's infinite values in an analog clock. If you have a digital clock, you're just gonna have like 12 o'clock, 12:01, 12:02. Like it's skipping a lot of these intermittent values. So what happens is, there's a lot of, since this is digital, we're skipping a lot of values and there's a lot of like precision lost, which is usually okay, because here's just an example of like how, if we move this up 1, we're kind of losing this many, like this is kind of like our accuracy. So for most of the stuff we do, that's going to be fine. Like it's not going to be a big deal. If we need more accuracy, we can go up and use something. If we're talking about like decimal numbers, we can use a double point floating precision number. And this is just an 8-bit, or sorry, 8 bytes data structure. So we have 64 bits to represent a float or a decimal number. Has anyone seen, there's also weird stuff. So, but the point here is with a 8-byte or the double floating point precision, it's not that we can count higher or count lower. It's just we're going to have more accuracy between these ranges. It's like all of a sudden, say we had a digital clock, we have going to double floating point precision gives us a digital clock with like seconds. It's still digital, but cool. So let's look at like colors. We kind of talked about hexadecimal. So when you look at your computer screen, there's 3 different colors. There's, if you were like to zoom in on the pixels, all your computer, there's only 3 colors on your screen. There's red, green, and blue. Does everyone know this one? Like there is, if you have a magnifying glass, you will never see any other color than red, green, and blue on your computer screen. Like if you want yellow, if you were to, like if I were to zoom in on this yellow and like look at the pixels, I would just see a whole bunch of red and green pixels. So, and one of the reasons we use hexadecimals for pixels is because it actually, it's a pretty conventional way, and it actually happens to be that, you know, we have these 6 numbers. So we've all seen this with CSS, where we do our pound, and then we can give it this 6 values. Well, if you do it in CSS, if you do pound FF000, that's going to be red. So the first 2 digits are going to be how much of the red value you're going to have. The second 2 digits are going to be how much of the green value you have. And the last one is your blue. So it's RG blue. So what is, anyone want to try to figure out what the value of FF is? I have 1, or I have 15 ones, and I have 15 16. So it's 16 times 15 plus 15, which I believe is 255. Yeah, because so I can have 256 different values of blue, because I can have 0 up to 255. So if I have, like if this was halfway, like, I don't know, like 7, 7, then that's only going to be like half the brightness. And then that's how you can make colors. There's a lot of other systems, but this is kind of the basic one. Does anyone know it? Like, I don't know if I do off the top of my head, but if these are all full FFFF, like what number is that? Essentially, like that's like how many colors can you have? Because think, you could have 0, 0, 0, 0, you could have 0, 0, 0, 1, 0, 0, 0, 2. And you could count all the way up to F. Like what number is that? I believe it's like something like 14 million. It's 16 million. Does that make sense? So there's 16 million different colors you can represent in CSS or like on your computer screen. That's quite a bit, right? Apparently that is like the max of what the human eye can distinguish. I think that's like, sounds crazy that that's even true. So let's look at something just to kind of go more into this and kind of just talking about, maybe this will be also be like a little more visual distinction of the difference between digital and analog, and that's sound. So y'all know what a sound looks like right here, like at the top where you have like, just looks like a wave. We have a sound wave. So this would be like a wave, like a sound wave is analog, it's continuous. There's no breaks, it's this nice smooth curve. But we can't do that in computer land, you know, we have to do it digitally. So what we do with computers and sound is we have a certain amount, we have what's called a bit depth. So that would be like using like if I use 2 bits, that would be a low bit depth. If I used 1,000,000 bits, that'd be a very high bit depth. Like your Nintendo, like the first Nintendo that came out is like 8, I forget, is it like 8 bytes or 8 bits? So you have a very low, with your Nintendo, you have a very low bit depth. And then the other thing you can do is you can take, how many times are you going to sample the wave? So the less sampling you do, you know, you're going to kind of point that pick of the wave. So when you have a low bit depth and a low sample rate, you get a wave, you know, this looks like a wave, right? But there's a lot of like, it's very steppy. And this is like your 1990s Nintendo. It sounds very crushy. This is like distortion right here. But what you can do is you can add more to the bit depth. So you add more bits. And so then you can be more accurate about placing where it is, where it's matching. And then you also sample more. So you take samples of where the wave is. And then you can get closer to what the wave looks like, to the point where you can, you know, really get a really high bit depth and a really high sample rate. So if you look at like something like a CD bit depth and sample rate, so for a CD, they have 16 bits. So how many combinations or how high can you count up to with 16 bits? That's just 2 to the 16. Does anyone know what that is? Is that 1 million?
65,536.
Okay, 65,000. I used to have my things memorized. I don't anymore. So that's, you with 16 bits, you can count like that's 65,000 different spots. You can do it. And the sample rate is 44 kilohertz. So that's 44,000 samples every second. So that's what they're doing with like a CD, and that's pretty good. I think you can definitely do better. And if you have a good ear, that's not going to be the best, but that's what you're doing is 44,000 times a second. You're going to take a, you know, you're going to go ahead and put a little dot to kind of say where that wave should be. So if you can do a little better, why wouldn't they just make this like 16 bits or like 32 bits at like, 180,000 kilohertz? What's the downside of like making our bit depth higher and our sample rate higher?
Storage space.
Yeah. If we're going to need, if we make this 32 bits, we're going to need, double the space. If we, make that double, then it's quadruple the space. So it's kind of a balance between how much space do you want to use and how accurate do you want to get. So going back to the numbers, you might be like, well, I want to use a double floating point precision because it's more accurate, but it's like, well, what are you doing with it? You probably don't need it. It's the same reason, like they could definitely, this is really like with the colors, this is not that much storage, but why would we make this any more detailed if that's all the human eye can see? And that's kind of like with the CD, I think they found that as like a happy medium of like, this is to the spot where most people can't tell. They can't hear that distortion. If you go down to like an 18-bit or like 22 kilohertz, then you can start to hear that distortion. You can hear this, like that steppiness. Cool. So let's talk about RAM just really quick, just so we know this term. So just to make this clear, there's when I first got like a computer and knew nothing about computers, I really was confused about the difference between, well, memory and storage. Like to me, those two terms always seem the same. If you go look at like your computer, like about this Mac, you have memory and then you have storage. So, and if I look at like the storage, there's like 1 terabyte, that's like a ton. If I look at the memory, like this one has 32 gigs of memory, that's a lot of memory, but obviously the storage is a lot more. Like, I don't know how much, that's like 30 times more than I do have in memory. So I think the easiest way to think of the difference between memory and storage is what your computer remembers when your computer's off. So when your computer is off, everything is stored to your hard drive. That's another word for it. It doesn't, and it persists, that data persists. But what happens when you turn on your computer and you like load an application or something, like I go load Chrome or go load SQL Electron, that's going to load the program from my computer storage into my computer memory. And your computer memory is much closer to your processor. So it works a lot quicker with accessing that memory than it does storage. It's really, really expensive when your computer's on and you have to load something from your storage. I don't know if you remember this, like before like a hard drive or before like solid state disk, it would take like, 2 minutes for your computer to turn on, or like, 30 seconds for an application to load. It's gotten a lot better, but it's still very slow. So memory is just what's available to you when your computer's running. I don't know if I want to, maybe I'll show a little. So there's 2 types of systems. There's a 32-bit system. If you have I think these are, I don't know anyone who would have a 32-bit system right now. The downside with a 32-bit system is you can only go up to 4 gigs of RAM, which in today's age, that's kind of getting pretty minimal. But most systems now are 64-bit systems, and you can access whatever number that is, 18 quadrillion gigs of RAM. So we're probably going to be using 64 bits forever because there's no real reason to go more than that. I don't know if it's really something that's like kind of maybe a little hard to explain, but something that's pretty crazy is your like a 64-bit system. What that means is your computer processor is only getting 64 bits of information with like each computation. And it just goes through each of those sets of instructions really quick. It's kind of crazy how that works, but I'm not going to go. That is definitely a lot more in-depth conversation. But I do think it is important to know just the difference between storage and memory. Everyone got those two. Cool. One other thing that's kind of fun to talk about with talking about data is compression. Has anyone seen Silicon Valley? It's a good show on, I think it's on HBO, but it's about a whole bunch of nerds and kind of the premise who work in Silicon Valley, and kind of the premises they come up with this new cool app, which is really all about an insane compression algorithm that just changes, the computing world. Because compression is a pretty big deal. You don't really ever deal with it, but just kind of something that you might actually with like images. But if we're talking about compression, what you're doing is you're taking all of these bits, all of this data, and you're going to compress it into something smaller so you can then send it to someone. And then when you send it like via the internet, they can then open it up and then get back that original thing. Who do you think, like, what kind of example can you think of where you're going to use a lot of compression? Like what thing that you probably use every day?
Video conferencing.
Yeah, Zoom. Zoom is definitely doing this. Yeah, anything with video or images or text. I mean, it's essentially probably everything's getting compressed before you send it, but especially video and images. So Zoom, Netflix, anything like that. So there's two different ways you can do this. It's lossless and lossy compression. So lossless is you compress the original thing, and then when they open it up, they get all of the data back and nothing has changed. It's the exact same thing. There's lossy compression algorithms that will take your original thing, compress it, and then when you get it back, it's not the same. So I don't know if you can tell by these images and what this is trying to show. Lossy compression, the benefit to this is you can definitely compress it more. You can make the thing smaller before you send it. So definitely video stuff is doing lossy compression. They're doing also a whole bunch of other crap to make it where they can want to compress it so they don't have to send all that data. But so, and this works fine. The downside of this though, is if you keep on doing this, like let's say I have an image that I send to like Paul, and I use lossy compression, and then, he sends it to someone and uses lossy compression. Each time you're going to lose a little bit of data. So the effect of that would be like, if I had an image, every time I did lossy compression and sent it, it would get like a little blurry. And if I did it enough, at some point, it would kind of just become unrecognizable. Cool. So that is that. Just a little, I mean, really, this is a lot of information. I kind of just want to maybe get you at least thinking why we have, like, especially with a database, why there would be so many different types of data. Because it's just at the end of the day, you know, it's really, I mean, computers are amazing because, like, at the end of the day, we have to take something like a video, or we have to take something like text or an image, and we have to like convert it to zeros and ones. So, and this is just one example of like floating, like how someone decided to represent like a decimal. Like, okay, and this one's actually pretty common, but there could probably be a different way to do it. There are. Like, here's how people decided to represent colors. And part of the reason they decided to do this with colors, like this is the way that it represents colors, is because this is how your computer screen works. And this is how people decided to represent sound. Like, oh, let's just have a bit depth and take samples of it, and then we can like recreate a wave with that. Cool. Yeah, I think this is a good time for a break. Let's come back at 11, and we'll get into some SQL stuff. Okay, let's go ahead and get started. Go ahead and just open up Postgres Electron or the SQL Electron. And let me share my screen. This one is a little hard to, I like have to zoom up on this. I forget how I do this. Text on this is like pretty small. Let me see if there's a way I can like zoom up on this. It's not gonna do it. Right there it is. It's a little bigger. Okay. Sweet. Actually, looks like a new feature. Cool. So yeah, let's just get into some SQL stuff. But before we do, let's just look at some basic terminology. So this, I think we've kind of seen some of these terms. Like the database, that's the term describing the whole, our whole database of our project. We have a table. I think going through like the MVC, learning about MVC, we could think about like our table as being the database layer of our model. Another way to think of a table is just like an Excel spreadsheet where the rows, that's the actual data. So you're going to have your rows where you're going to store one individual records. And then you're going to have your columns, which are like your attributes. So that's our row and column. We have our primary key. We've talked about that before. So all database tables should have this primary key. And this should be unique. And this is just a good way to look up a row in your database. So then you can find one individual record. We've seen not null. So sometimes we can say, hey, sometimes our values need to have, have actually not be null or we won't save them. You could have something like unique, where it has to be like an email or once again, a primary key. These need to be unique, meaning they shouldn't match any other values in our data, in our tables. Now, one of the nice things about SQL, we're just going to look at some of the some basic commands. One of the nice things about SQL is these are very readable. You write a SQL statement and it's kind of describing what it's doing. So you've never learned SQL, but I bet you know what these are, because these in caps locks, these are the commands. So bet you can kind of guess what these commands do. So select, that's going to get data from the database. We have update, that updates data. Delete, that's a way to delete data. Insert into, inserts new data. Create database, alter database, create table, alter table, drop table, create index, drop index. So here are the SQL commands, and they kind of describe exactly what they do. We have some constraints. So when we talked about like validation, I think we can have like validation on our front end where we're doing it in JavaScript. We can have validation in our models. We can also have database validation. So in our database, we can make sure like a column's not null. We can make sure it's unique. We can describe something as a primary key or a foreign key. We can check a condition. We can give it a default value if nothing's supplied. And I'm not gonna talk about indexes today. So yeah, let's go ahead and just open up SQL, our SQL Electron. Now this one, you do not need to be, I can just go ahead here, connect. We don't really need to be connected to our Rails database. We're just going to start from here. So you don't need to connect to a Rails database. This is going to be, today is going to be independent of Rails. We're just using this SQL Electron app. Just going to kind of do everything from scratch. So the first thing I would need to do is create a database. Now, we would normally do that in our Rails app by creating a new Rails project and then doing Rails DB create. But if I just wanted to create a database, I can come in here and I can start writing some commands. Create database. Now, with SQL, you'll see this convention of capitalizing the SQL commands. You don't have to, it's going to work. This could be lowercase, but it's kind of a nice convention because then you can see what is SQL and what's not. So I'm going to create a database and I'm going to call this dealership. And with SQL, if I use a semicolon, or I should say Postgres, this is technically Postgres that we're using. If I use a semicolon, that's going to end the statement. So I can hit execute, and then there it is, query executed successfully. So now I have this dealership. So I could do something like, I have my database now. The next thing I want to do is like create a table. So let's go ahead and create a table. So cars. So this would like, maybe if we, instead of doing Rails G model cars, we're just creating a table in our database. So create table, that's the command. I'm going to create a table named cars, and then inside of here, I'm going to give it the columns. So I'm going to give this an ID. And this is the type. Remember, serial was that like auto incrementing integer. That was a data type. And I'm also going to say, hey, this is a primary key. Come in here, we could give this, like this has a make. So this is me saying like, oh, make is a string, but we don't have a string data type. We have this varchar, which just stands for varying character. The 50 I'm putting inside of here is kind of like the max characters I think there's going to be. Like, I don't think a make should maybe have more than 50 characters. And then I can also come in here and say that can't be null. Could do a model. And if it's a string, I can just call it a varchar. That one, just kind of come in here and say, yeah, that can be greater than 50, not null. Do a year. That might be an integer. You can say, hey, this one can't be null. If I have not null there, that means I can, when I create a car, I don't need to throw that year value. We'll just throw these all in here. So we have a color. Let's go ahead, make that one a varchar. That like maybe 25. Say that's not null. And I could give it some mileage. Integer. Not null. I could do like a runs. That could be a Boolean data type. And maybe this one, if they don't give me a value, when they create it, you need to spell default, right? I'm going to default this to true. So this would kind of like, if I were to do this in Rails, this would be like Rails G model car make, let me make sure I spelled model wrong. Make, just string model, string year, int, color, string, mileage, int, runs, Boolean. Let's see here. Near make, oh, I forgot. So it's just some different syntax there. So it's saying I have a syntax error near make. So it's like saying somewhere around here, I have a syntax error. I'm forgetting a comma right there. Cool. So now I've created that data. Or sorry, created that table. So now I should have a cars table. So now if I want to actually add something into my table, I'm going to do an insert into cars. And then I'm going to say what I want to add in here. I'm more or less giving it the order. Like I want to do a make, model, color, year, mileage. Then I can say values. So now I'm just gonna like, give it like a Jeep. Now I can actually throw in some values, Wrangler, single quotes, white.
Do we want to be in the dealership database that we created, or does it matter?
I did it in here, so we're gonna be connected to it. Because I'm just in like this Postgres one where I did it. So if I remained in that one, it's gonna be right there. Kind of. Does that make sense?
Yeah, that makes sense.
All right, and then let's get that 1000. So I'm saying insert into my cars table these columns, and then here are the values. Execute that. And now it's saying I have affected rows 1. So the single quotes are necessary here. We're going to use single quotes to wrap the bar char values. We can use double quotes for like names of tables and fields, but if it's a bar char, which our make, model, and color are, I'm going to use the single quotes. Semicolons, as I said, they mark the end of the query. They're not needed, but sometimes that can help. With this in particular, because sometimes what might happen is, let's say I want to like, I'm going to say Jeep 2 and make this, I don't know, black. Sometimes with SQL Electron, you'll have maybe like just one line highlighted and then you run it. And it's not doing it now, but sometimes it will actually just run that one line and then you'll get an error. Actually feel like that might have, yeah, I think that kind of did it wrong, because that actually, yeah, that did. I'm getting this column 1, column 2. So something I want to do is like highlight it, make sure it's all highlighted. So yeah, what I'm going to do as well, just so we don't have to type this out, I'm going to slack out just so we can put some data into our database. I'm going to slack out this query you can throw inside of here. Because what you can do with the insert into, we can do multiple ones at the same time. You can do the insert into cars and then give it the values, and I can just give it multiple things to throw in there. So if I hit execute, see that's affected 7 rows because I added 7 things.
So where it says default there, could you have it say true instead and it would do the same thing?
Yeah. And if I don't have that in there, it's still going to set it to true. So that first command I ran, it didn't have the runs. Didn't have the runs, haha. It didn't have that attribute in there, but it's going to default that to true. That this first one I did. So this Jeep Wrangler white, the run should be true on that one. When it comes to like working with Rails and working with databases, like the whole like creating tables and creating databases, you're not going to do that with Postgres. What you are going to do with Postgres in combination with Rails is what we're kind of getting into next, and that's like selecting stuff from your database and kind of filtering it out, joining tables. So let's go ahead and look at that. So there's the select statement. This is you're going to get familiar with. Select star from cars. See, there's our 2 Wranglers we created without adding any of that, and those default to true. So select star from cars. This is just essentially, you know, if this was Rails, right, this would just be like a, when we do a car.all method, behind the scenes, you know, Rails is going to do something very similar to this. Like it's going to create this statement. To actually go grab all of those cars from our database. Cool. Something else we can do. So the star just means, hey, grab everything from this table. We can also give it specific columns. So I could say like, hey, grab make and model from cars. Now, when I do that query, it doesn't give me all that other information. It just gives me the make and model from cars. Let's go back to our star command so we can see it. So another thing we could do is we can use a where clause. So in here we can throw in some condition. So we can say, hey, select star from cars where, and you know, maybe I want to do like cars mileage, you know, is less than, you know, 40,000 or something. So I have a couple cars, like this Jeep has, you know, 320,000, this has 100,000. So maybe I want to filter out all the ones that have a lot of mileage. And now I only have, now this is giving me back 4 rows. So that, remember, this is a row, and you can think of one row. Another word you might hear one row card is a record. It's one car. And then going down, those are our columns. So make is a column, model is a column. Cool. But once again, this is very readable, right? Select star from cars where car mileage is less than 40,000. We can throw in and statements. So I could do, you know, cars.year, you equals 1999. Now, just a little difference here. It's not double equals, it's just one equal sign. I can throw in like an and clause. Cars.make equals Ford. No. Go ahead and execute that. So here the year is 1999 and the make is Ford. There's a or statement. So I could do an or right here. So grab me all the cars that were made in 1999 or their make is Ford. I think so that was, I had that or highlighted. I think that's why I got that error. So that's grabbing me all my Fords, etc. See if there's anyone like 1990. Guess we don't have one. So we can use an or, like in this where we can just mix and match with or and ands. Just count that follows the basic logic that it would in Ruby or JavaScript. There's also a not keyword. So I could say, grab me all the cars where not car.make equals Ford. Or not seen from clause or
It's cars.make.
cars, there it is. I should read my errors. Missing from clause entry table car. There we go. So now I'm not grabbing any of my Fords. We could do something like we can select all from cars and then we can do our where clause. And then there's a, well, let me just show you this. Let's get rid of this where clause. I can like order by cars dot mileage. Execute that. So now it's ordering by the mileage. I can do descending. So there's DES. So by default, it's ascending. If I want to do it descending, then I'll just write this DE descending. And yeah, you can combine these. I could do like where, car.make equals Ford, and then descend those cars. Keep on doing that. Cars.make. So grab me all the Fords and then order them by mileage. All right. Let's go ahead and do an update statement. If I want to update something, update cars. And then I can do like let's see these ones. So these both, this one has the true and false on the run. So let's go ahead and do a set. So I'm going to update cars. It's like frozen. Give me 1 second. Set. Why is it not typing here? Issue here. It wasn't letting me type. So I'm going to, I can do an update my cars. I can set like runs. I'm going to update an item. I want to be careful with this one because if I were to run this command right now, it would actually update runs defaults on all of my cars, but then I can just combine this with the where clause. Or maybe car.id equals 8 cars.id. That one right now is true. I'm going to switch that to false. Do a select. Show that select star from cars where cars dot Ford, or let's just do cars.id because that's the one I updated equals 8. Scroll over there. So now that's been updated. There's also, if we want to delete, once again, I can delete from cars. Have that lowercase. Once again, this would work, but this would delete all my cars. So I probably want some sort of where clause. And yeah, I mean, I could do something like this, dot make equal Ford. Capital Ford. That would delete all my Fords. Notice how that deleted 2 rows. So now I don't have any more. I shouldn't have any more Fords. So select star from cars where cars.make equal Ford. I don't have anything because I deleted them all. All right. So yeah, you can get pretty specific with like finding stuff. So let's just do select star from cars. And we can do a pattern. So there's 2 symbols we can use that we can use. There's a %sign. This is going to represent 0, 1, or multiple characters. So it's a way we can kind of match things, and I'll kind of show you what this is in 1 second. There's also the underscore, and that's going to be a single character. So let's kind of show you what I mean. So I'm going to do select star from cars. And I can do something like this where cars.make is like, so I want to kind of match this. I'm saying it's like this. And this is what I mean with the %sign, it's going to match anything that starts, if it starts with a J and then there's anything else, it's going to match it. So I have a Jeep, I have a Jeep 2, I have a and I have a Jaguar. If I put in like an A here, like JA, and then execute that, now that's only going to match my Jaguar. With the underscore, that's just 1. So I'm saying, hey, just match all the ones where it's like, it starts with the GE and then has 1 letter, because I do believe there was, just comment that out, 1 like a Jeep 2. Yeah, I have a Jeep 2. So it doesn't match that one because there's a 2 behind it. So if so you can kind of think of it like this. I don't know, let's maybe go into the model. Let's kind of give you this quiz. If I did like a underscore, or let's do a %. Let me kind of look at some of these. What would be a good one? They're all pretty different. %, I don't know, R %. What is that kind of saying?
Like a R in the middle of a word.
Yeah. That's just like any amount of characters and then an R and then any amount of characters. I think that should match the Prius. We have the Cherokee. I believe these are case sensitive. So if I do a capital R, that's going to match my Wrangler. It's also matching the RAM. So I guess that's, I guess that's going to match that even if it starts with it. Cool. So yeah, I could do if it starts, if there's one letter and then an R. So this should only just match the Wrangler. So I did, underscore. I mean, these ones get a little more specific, underscore, like A. That still matches it because it's like, hey, check for the 2 characters and then an A. Or you could do something like this where it's like starts with a W, then there's anything and then ends with an R. Shouldn't that be my, oh, sorry, that's not the right sign, percent sign. All right. So let's go ahead and just look at a couple more. So your homework today, what time is it? And I think it's better, like your homework for today, we're going to send you to a website that kind of goes through all of these and gives you the practice to type these out. The main thing I definitely want to make sure I go over is the join statements. So I might skip some of these. We can also do like a where like cars.make can give them like a in. So we could do like, is it a Jeep or is it a like Toyota? So I can maybe match a list of things. So that gives me all my Jeeps and Toyotas. I could do a between, so maybe I have like a mileage. Is this mileage? Give me all the mileages between. 1,000, let's do 999 and 50,000. I guess I just had 2 cars with 1,000. Let's make that 100,000. So if I do 100,000, that's going to just grab all the cars within the, add that mileage between those values. Something we'll do when we get into like joins is you can alias these things. So I can say select star from cars as C, and I'm just giving this cars an alias. If I run this now, this is going to break because I'm changing the name of this. So now I can refer to that later as car, sorry, just C. So I can alias this table. So we'll start to do that when we get into queries. Time is it? Cool. Let's just get this set up, and then maybe we'll take a break, and then we'll get into some queries. So let's see. I think I'm just going to Slack this out. So here's our first query. To create, we're just going to create a new table. One thing I do want to point out with this query that we're just doing, so we're creating a parts table. It just has an ID, name, description, serial number, broken, and a car ID. And this references cars. So what does this kind of make you think about as far as like Rails land is concerned?
Has many.
Yeah, it has many. So how would you
Like car has many parts.
yeah, car has many parts. So this would be like when we're generating this parts model. So and you're right, that's how you would say a car has many parts. But when you did the Rails G parts or Rails G model parts, you'd say car belongs to. But how we're going to do this in SQL is we give it this car underscore ID column. We're going to make it an integer and we're going to say, hey, this references cars. So we can run that. Cool. Let me just do something right here, just to kind of show you. If I do random, and I don't know, just times it by a number. See if this works. Random. Do I need to do a select on this? Maybe I need to floor it. I feel like I'm forgetting a floor. So I'm doing this weird select statement, but what I'm doing, I'm just, remember floor, that is just round down, and I'm just calling this random function. This is a SQL function, so I could just make that uppercase, but random. That's just generating a random number. If I just do random, I could also do this. I could select, let's just say select ID from cars. And then I could say order, or let me do this, select ID from cars. Let me run this. That grabs me all my IDs. I could limit, there's also this limit. I could say limit 1. So that's just going to give me back, 1 entry. If I say limit 2, that's going to give me back 2. I'm just going to show you this because I'm going to copy and paste this. But what I could also do is I could select ID from cars. I could say order by. And then I'm going to do random. So that makes them random. And then I could just say limit 1. Now I have this query that selects an ID from my cars, and it just it just kind of gives me a random ID from my cars table. So if I run that, I'm just getting back 1 query. Just kind of wanted to show you that because this next thing I'm going to slack out is using those 2 things. Sorry, give me 1 second. Okay. Just trying to throw in some data into our database. So we created our parts table. Now we're just the same way we did with our cars. We're just going to throw in some dummy data. So we have some name, description, serial number, just coming up with a random number. But our car ID, that's where I'm just selecting a random ID. So I have these two kind of nested SQL statements where I'm just, select a random number and then, hey, also select that random ID from my cars table. That's what's going on there. And now I've created 4 parts. So now I should be able to select star from parts. And there we go. So I have my like 4 parts, and there's the car IDs. Now these probably won't match yours because we kind of did it randomly. But I have some random serial number and then some random car ID. But let's take a break. But when we get back, what we're going to do is we're going to talk about how we can now interact with these 2 tables, because now these 2 tables are associated. But we don't have like our Rails methods now because we're not using Rails. So now we just have to use SQL to kind of get some of our information, but with this nested table. So, because I mean, something else you can do with this too, with, and this is where you do want some semicolons. I can run multiple queries from here. So here's all my parts, and then here's my second query. There's all the cars. So you can do multiple statements, but here, if you don't have the semicolons at the end of the statements, then it will break. So kind of let SQL or let it know which ones are which queries. Yeah, let's take a break. We'll come back. We'll talk about joins. So let's just do a quick 10-minute break. Come back at 11:45. Does anyone have any questions? I'll stick around for a bit if anyone has any questions. No. See you in 10. All right, let's get started. So we're going to talk about what's called joins. Share my screen. I'm going to also Slack this out, this website. So I think it's joins are easier to see kind of visually. So we created two tables. We have a cars table and we have a parts table. Maybe we want to do a query that accesses, that gets data from both tables or more than one table. And to do that, what we can use is what's called a join. There's a couple different kinds of joins. But essentially it's just a way to grab different columns from different tables into a single query. So let's just look at this little example. So, and this is using what's called a inner join. So here in this example, they would have two tables. They would have a Facebook table and a LinkedIn table in their database. And they're going to join these on a given condition. So here, they want to join two tables. So they have a select star from Facebook and join the LinkedIn table where the Facebook name equals the LinkedIn name. So that's the basic syntax of a join statement. And then this would give you back a query with the Facebook.name and maybe the number of friends on Facebook, and then the LinkedIn name, and then the number of connections on LinkedIn. So it's kind of taking two tables and combining them together. So what it's kind of showing us here is we have just like on the left here, where we have this Facebook table. Here's like some dummy data, Matt, Lisa, Jeff, Sarah, and how many friends they have. And same thing on LinkedIn, Matt, Lisa, Sarah, and Luis. So notice like someone like Jeff is not in the LinkedIn. That name is not in the table. But all the other ones, Matt, Lisa, and Luis is not either. So Matt and Lisa are in here, but Jeff and Sarah are unique to Facebook, and Luis is unique to LinkedIn, right? Okay. So when we do a query, a join, and this kind of shows it matching. So what it's going to do, if it finds a match, it's going to throw that match into the database. And notice how it's looking through all of the things. So it's going through Jeff, and then it looks through all the other ones. It goes to Sarah. It's looking all of them. It finds the match. Now it doesn't stop. It keeps on looking. And it combines those two those two tables together where they match. So Jeff is not in here and Luis is not in this final column because that's the inner join. They have to match. The other way you might see the inner join kind of represented is a Venn diagram like this. So you have table 1, table 2, but only grab where they match. There's a left join. There's also a right join. They're kind of the same thing. The left join looks like this. Let's kind of visually go see what that's doing here. So we could have so what we just looked at was an inner join, and that's where they have to match for them to be added to the query. But if we do a left join, so here we're doing a matching Facebook left join LinkedIn. Notice the difference here is where Jeff is in Facebook, but there's no Jeff in LinkedIn. Since we're doing a left join, we're still going to keep Jeff in this query. It doesn't have to match. So Jeff comes in here now, since that value is not in the LinkedIn, these values are going to be null. But we still grab that value. So it's like we grab everything from the table, from the Facebook table, and where we match on the LinkedIn table, then add those values. If we don't match, then throw in null. And yeah, right join, it's kind of this, the inverse of a left join, like, so you can really do everything with the left join. You just be like reversing the table names. So I don't think this one's really used that much. There's a full outer join, which is going to match everything. So in the case where like Jeff is unique on our Facebook and Lewis is unique, they're both going to be added, but their values are going to be null. So I wish I could pause this right here. See, Jeff, his LinkedIn name is null at LinkedIn because he's not in that table, as likewise where Luis is not in the Facebook table, those values will be null. So the one we're going to use the most, so I'd say full outer joins are kind of some of the least used. Left joins have, I mean, it's not to say they're not used, but the one we're going to use the most is the inner join. So let's write a query. Hopefully this, I think this website is a better illustration, because what you'll normally see is sometimes these Venn diagrams, which I think can kind of be a little confusing. But this actually visually goes through the query and does it, kind of explains the difference between the inner and outer joins. Okay. So let's go, we have our two queries here where we select all the columns from our parts and all the stuff from our cars. Now let's go ahead and join these. So what I can do is maybe I want to select, I'm going to show you this. I'm going to do, let's p.name. So maybe I want to grab the name of my part. And then I'm going to also alias this as part underscore name. And I'm going to grab that broken. And I'm going to grab the serial number. Also going to grab the car.make and the car.model. So I'm grabbing different columns from my different tables. I'm going to do this from cars as C, because I'm calling this c.make, c.model, just to kind of alias that. And I'm going to say inner join parts as P. So that's where I'm aliasing that. So I can call this p.name, p.broken, p.serial number. And then I'm going to do this join on where my part dot car underscore ID equals my part ID. I think put a semicolon there to end that query. At or near, where's my syntax error? The dot.
I
Oh,
think you need a comma after p.broken.
yep, I do. And also I have this should be equals car.id, where the p.car underscore ID equals the car ID. And maybe just to show this, we can do like the c.id and the part. Just to keep this a little clean, I'll throw that here, the part. So we can see these car underscore ID. Help show what's going on here a little better. So the part.car ID, that here it's 7724. Notice how those are, that's matching these IDs, because that's where we're going to match these. This join statement is on the IDs where our part car underscore ID equals the car ID. And then if those do match, then I'm saying, hey, for one of these records, grab the part.name, but let's rename this as part name. So notice how in this column it's called part name, because I changed that. I could also grab broken, the serial number, the car ID, the make, model, and the ID of the car. Now, this ID right here and this car ID should be the same. So this makes it as to rename that. Not that I would, that's the bad name for it, but just to be clear, right? This is the ID from the car table. This car ID is from the parts table. See how I'm joining these two tables together? So, and I can do the join. I can also just from here, I can also just keep on doing, some queries. I can do a where statement. So now I have two ones. So these two are false. So it should just grab these two now. So there we go. Order by part dot serial number. I don't know why I do that, but cool. So that is a basic example of a inner join. Taking two tables and then combining some of the stuff. Let's maybe look at a left join. So I might want to do something like select. I'm not going to alias these, make or model year, color, mileage. Let's try this mileage, name, and serial number. I forgot, does our cars have a name? No, it doesn't have a name. Where you might need to alias these is if you have, and this happens quite a bit, is if you have columns that have the same name. Say for instance, ID. Well, let me just get this working, and then we'll go back to that. Cars, and then we'll go inner join. Oh, let's do the left join here. Left join parts. Let's alias these right here as C. As P. I'll just do this on our car.id equals our part.car underscore ID. So it looks the same as our inner join. It's just, oh, now we're just calling it a left join. Oh, serial does not exist. It's serial underscore number, right? Okay. All right, so I'm trying to think where our duplicate column is. So here we're getting a warning, duplicate column's name, it may cause the result in the second column overriding the first one. Oh, it's because I have that in there twice. So notice, since I'm doing a left join, it's going to match. It's going to give me back all of the cars, even though they might not have a part associated with it. So if it doesn't have a part associated with it, it still gives me back the card table data information, but for the part information, it just gives me back null for those values. Because my car has many parts, and in this particular example, like my Prius doesn't have any parts. So if I'm trying to do a join and I'm doing a left join, it's still going to say, hey, grab all that car data anyway. Just don't, these will have to be null. If I do the inner join, then they have to match. And so I'm not going to grab any of that car data that does not have a part associated with it. That's another way you could think of it in this example. If it's an inner join, it's saying, hey, give me all of this car and part data for all the cars that have parts. If I do a left join, it's saying, hey, give me all the car and part data, even if the cars don't have parts. And if the car doesn't have a part, we'll just have to go ahead and like set those values to null. Now, something else I did here that's a little different. Here I'm using the p.name, p.broken. Here I don't have to do it. But let me show you where you would have to like be specific. What happens if I say ID here? And try to run this. Now I get an error saying ID is ambiguous. So what's going on here is remember both my car and my part have an ID table. An ID column. So it doesn't know which one I want to get. So I have to tell it either give me the car ID. And then when it says ID here, this would be the car ID. That looks wrong though, right? 'Cause why don't those match? Let's see. That doesn't look right.
I think that's your first query of just all the parts.
Okay. Oh, you're right. Okay. You're right. Okay. So sorry. I got too many queries going on. I'm gonna comment those out. Okay, there we go. So there's the ID of the car. If I did, part ID, then the ID would be the ID of the part. So here for obviously the ones that don't exist, that'd be null. But I could also, if I wanted, here it's called ID. Maybe I want to be a little more like get both of them. Well, this isn't going to work either because now I have two columns with the same name. Why is this not letting me type? C.ID. I have it works, but now it's going to get confused because it's like, which ID is it using? Well, it's actually just looks like it's using the part ID because that's the last one. So then I could, because now I have two ID columns, but it's getting confused which is which. So here I could alias this as a different name. So now it knows, okay, that's the car ID and this, I'm just going to call it ID, but that's really the part ID. But I might want to clarify that. And I can kind of change the name of these columns. And I just copied the JSON because when we hook this up with Rails, you know, this is what your JSON is going to look like when you do your Axios call. You're going to do an Axios call to this. We'll see how we'll hook this up to Rails, but it's like Axios.get like my custom method in Rails, and then I'll get back this data with the make, model, year, color, mileage, name, serial number, car ID, part ID. So yeah, that is, let me see what else. That's a join. Let's just see what happens if I'm not quite sure. Let's make this an outer join. I don't think we have any parts that are on their own. So I don't think this is going to do anything different. Outer join, except it's going to break. Doesn't like the outer. Oh, maybe it's just join. Let's not grabbing it. Or is it full outer join? I'm getting my SQL and yeah, it's full outer join. So let me just to review this. If I do a full outer join and a right join, or sorry, a left join. These are going to be the same. Why are these the same in this particular case? Like they're going, by what I mean they're the same is they get back the same data.
There are no parts that don't match a car ID.
Yeah, exactly. So since there's no parts that are kind of, yeah, don't match the car ID, there's not going to be that mismatch where, you know, it's not going to just come back null. We're going to have a part and then all the car data is going to be null. If we had a part in our database that was not associated with a car, then all that car data would come back as null. So let me see what else. there's just, I mean, these aren't ones we're going to use, but there are commands like we can drop a database and then give it the name. Cars, we can drop a table. I'd say when working with the Rails, though, we're just going to use our Rails G. We're going to want to use our CLI tool if we're creating stuff and migrating stuff. We're not going to want to do that with SQL. Think about, we're going to want to use SQL when we're like wanting to, when we actually have our database created, our tables created, and we just want to do these queries where we're either filtering data, we're joining tables, that kind of thing. Let's say for like dropping tables, altering tables. So there's drop table, give it the table name. I could alter table, to change, you know, be like add, column name, etc. The data type. For all of these, we want to use Rails. And if you're using other frameworks, I know like with SQL, it kind of be like, or the Microsoft SQL Server, you're probably going to have migrations and things that you're not going to do this with just raw SQL. We're probably going to want to use the tools of your framework to do it. But at the end, when you do run those migrations, when you do like the Rails GB migrate or Rails DB create, behind the scenes, they are using these SQL commands. Cool. Let's just look at just the date types really quick. Just because you'll see some different date types. So there's date, time, timestamp, year. Just note like sometimes like a date is just going to have the date. A date time is going to have the date with timestamp. So for a lot of these, and I think with Postgres, these just match up with these MySQL ones. So those are the different kind of dates. Yeah. We'll probably do some stuff with dates with the lecture coming up this week. So you might get some exposure. But for today, I think that's about it. I think you're going to best learn SQL just by kind of just typing it out. So the homework today, and I can just give this out now. Just this website right here. And there's really nothing to turn in. So it's kind of on your honor type thing. But this, what's wrong? Sorry. This is a really good like interactive kind of homework assignment where you get to go through and kind of, it's just like a whole bunch of interactive tutorials. So you're going to go through this, you can read up on it and then kind of test your knowledge. So there's about, I think there's like about 20, let me see. Yeah, there's about 18 lessons. So they kind of get progressively harder. So it starts out pretty simple and then gets progressively harder. So what you do is, you know, you can go through, read through this. So it's going to kind of explain before you start to challenge. But then when you get the challenge, like for instance, like find the title of each film. So you have to come down here and make it work. And it kind of like automatically like tries it out. So you don't have to hit enter or anything. So now that that one's done, I move on to the next one, like find the director. So select director. Title and director. So this, yeah, they do get harder. So you kind of go through. But it's kind of good. Take your time with these, like read these. It's got a lot of explanations in here. And then you get to kind of like try it out. I do think another good one is if you get done with this, W3 Schools has a decent like SQL where they have, I think this one's, where's the one? This one's kind of nice because you can go through and you can kind of like look at your tables. So it gives you kind of like this kind of small real world database with like some dummy data in here. So you can go through and like try some of these queries, but then like, you know, it has a lot of, you know, the inner joins. You can try it out. It's good practice. So I think this, I'm not a huge fan of W3 Schools, but I think this is their SQL section's pretty good. So if you get done with that, yeah, you can either go through the W3 Schools, or another thing you could do is try going through one of your databases. I don't know if I don't have any in here, which is go through one of your development ones that you've done in Rails and try doing some SQL with one of the ones you're familiar with. I just created this one that has a things model, remember? So you could go through one of your actual Rails databases from one of your homework projects or personal projects and just try doing some SQL commands on that. I would definitely suggest using one that has like a has many through, or like a has many, so you can try doing some joins. Not that it has to be a has many to do a join, but that's generally where you're going to use those, is when you have related tables. Cool. Any questions on that? I'm not even, let me get this out. Really, there's nothing you need to turn in for this one. So I'll just make sure you can see it. Wait, what? Oh, back. Does anyone here feel like 2021 like was like such a quick year, like it didn't exist? This was like a blur. It was such a weird year. Cool. Well, that is it for me. So if that is it, yeah, let's just come back at 1:30. Sound good? Cool. Have a good lunch, everyone.